Okay guys, here's another installment of Math with Mrs. Matthews. Today we're going to talk about rational exponents. So rational exponents are just a way to convert from something called rational form, meaning it has an exponent, and radical form. So the difference is, so this is all in referencing your note packet, is this and this are equivalent. So the baby number that was our index, meaning whether it was a square root, cube root, fourth root, that becomes the denominator, and whatever the exponent was on the variable becomes the numerator. Now, a couple things to keep in mind. Honestly, the most important thing of the entire lesson is that you know if you have the square root of x, there's an invisible 1 right here, and then this is a square root, and I said there was an invisible 2 right there, so this is equivalent to x to the 1/2 power. Or just like if you have the cube root of x, right? There's an invisible 1 right here. This would be x to the 1/3 power. So if you see 1/2, 1/3, 1/4, that's just square root, cube root, fourth root, and so on. And you need to simplify as needed. So if you look at the example, so this is starting with the example section in your note packet. So the first example says x to the 1/4 power. So this is an easy one. So the denominator becomes the baby number outside, and the numerator becomes the exponent. Now, do I need to write x to the first power? No, you could just write the fourth root of x. Number 2. So I have 15n, and again, it's in parentheses. That does make a difference. To the 1/2 power. Again, 1/2 power means square root. So all this is the square root of 15n. Okay, now you can't reduce that because there aren't any powers, there aren't any perfect squares that goes into 15, and n doesn't have a pair. And just like number 3, I have 24 to the 1/3 power. Remember, 1/2, 1/3, 1/4 means square root, cube root, fourth root. So this means the cube root of 24, which technically you could simplify, but for right now we're just going to leave it. If you keep going, and again, these ones go kind of quickly, but if you need me to re-explain anything or let me know, please email me. On number 4, this is 7 to the 2/3 power. Now, if this has a numerator and denominator, remember the bottom number is the type of root, so this is a cube root, and then this would be 7 squared on the inside. Now, you could leave it like this, which some of the questions, depending on what our test is going to look like, I don't know, just have you rewrite from one to the other. You could also rewrite this as the cube root of 49, because 7 squared is 49. If you see, like number 7, it says AB to the 3/4 power. Okay, if these guys are in parentheses, they're there for a reason. So again, denominator becomes the type of root, and this becomes the exponent. So technically this is equivalent to this, okay, because that 3 would affect both of these in terms of an exponent. And sometimes the regular worksheets, like the Gina Wilson worksheets, leave it like this. And sometimes the one that I make on my computer with a different program also write it like this. But these two things are equivalent. So if you see either of these, both of those are correct. So then on the bottom section, it then wants you to take it from a radical to an exponent. So if you look at number 10, it says the cube root of 16. Well, again, what number is hidden as an exponent? Well, this is secretly 16 to the 1/3 power, or 16 to the first power. So if I rewrite this, this is the numerator, and the power is the denominator. So this would be 16 to the 1/3 power. Number 11, again, this is why I said it was super important to pay attention at the beginning, because I said there's an invisible 1 right here, and there's an invisible 1 right here, because square rooting is the same thing as it to the 1/2 power. So this would be xy to the 1/2 power. And again, since both of these are inside the radical, you do need to put this in parentheses. It does make a difference. Just like with, so number 12, we'll just do a lot of these because they don't take that long. Number 12, this is the fourth root of 8w. And again, this is secretly to the first power. So I would rewrite this as 8w to the 1/4 power. And then again, so 15, another tricky one, if you see the cube root of 3m to the 7th, again, this is showing how you can write it both ways. Just remember, there's a hidden 2 right here because it's a square root, so this would be 3m to the 7/2 power. You can also have questions that have variables, but we'll talk more about that on the back. So go ahead and flip to the back of that note packet. So on the back, they're going to have you rewrite it as a radical, and then we're going to simplify it. So a couple things to remember. When adding with exponents, or when multiplying with exponents, you add the exponents. When dividing with exponents, you subtract the exponents, and you may have to come up with a common denominator, so fair warning. Okay, so remember that. Multiplying, you add exponents. Division, you subtract. So number 19 says x to the 1/3 times x to the 4/3. Well, we just said if you're multiplying, you add your exponents. So it's 1/3 plus 4/3. So 1/3 plus 4/3 is 5/3. And then we're supposed to rewrite it as a radical. So again, this would turn into a cube root of x to the 5th. And we're just going to leave it like that. We're not going to simplify just yet. Most of the time, we're just going to simplify if there's a number inside. So number 20 says p to the 1/4 times p to the 3/2. Again, if I'm supposed to add, I currently don't know how to add 1/4 and 3/2 because I have to have a common denominator. But I can write them both as powers of fourths. So I can rewrite this as p to the 1/4. This could be p to the 6/4. And then I can add them together to be 7/4. So you can rewrite this as this. This would be your answer. Number 21. So division. So I've got m to the 5/2 over m to the 7/4. Again, can I currently subtract 5/2 and 7/4? Now, if you go back to middle school, we may have forgotten how to come up with a common denominator, but my common denominator would be 4. So my top would be 10/4. My bottom would be 7/4. And then I can subtract these. So 10/4 minus 7/4 would be 3/4, which then I can rewrite as a radical. Okay? Then we come across some of the ones with numbers that involve an exponent. So if you look at, let's just go with number 25. So a couple things. When I made a copy of this, do you see how this fraction looks extra long on your 1/2? That's because this is a negative. So first rule that we need to remember when talking about exponents is if you come across a negative exponent, that means it goes into the denominator. So this and this, and becomes positive, are equivalent. But then 1/2 means square root, right? So square root of 100, but the square root of 100 is not 50, it is 10. So this is equivalent to 1/10. So same thing for 26. So 26 actually says 16 to the 2/3 times 16 to the negative 1/3, even though it doesn't really look like a negative. But if I add those exponents together, that equals 16 to the 1/3. That means cube root, so cube root of 16. But in our list of cubes, what perfect cube goes into 16? Well, I can rewrite this as 8 times 2, which this is 2. So this would be 2 cube root 2. So again, I added these to get 1/3. I rewrote it as a cube root and then tried to break it down using 2 cube roots too. You can also do ones with a negative number if it's an odd index. Okay, so this guy says negative 216 to the negative 1/3. Again, to get rid of the negative on the exponent, turn it into a fraction. And this means the cube root of negative 216. But if you have your list of cubes out, 216 is a perfect cube. So this should just be -1/6 because the cube root of this is -6. We don't generally leave a fraction on the bottom of our denominator, or a negative in our denominator. So then if you look at, say 29, a couple of these get a little crazy at the bottom. I got the cube root of v times the cube root of the square root of v. So this would be 1/3. This would be 1/2, which technically we said previously we couldn't do. However, we can create a common denominator. So this would be to the 2/6. This would be v to the 3/6. And then add your exponents. So this would be 5/6. Technically, if you wrote it as a radical, it would be this guy. And then I think there is one question on the homework packet in which you have to subtract. So if you look at 31, it's the last one, I think. I have 4 over cube root 4. So again, this is 4 to the first power. This is for the 1/3 power. I'm going to minus my exponent. So 1 minus 1/3 is 2/3. Then you can technically rewrite this as the cube root of 4 squared, which you could rewrite as 16, or you could just leave it like that. So some of them do get a little bit tricky, but nothing too crazy. Now, I did mention this in class on Friday, but the assignment over this is the front and the back of worksheet 6, homework 4. Okay, but I did tell you to cross off 13, 13, 16, and I believe 20, because those ones were a little bit crazy. So you could cross off 13, 16, and 20. You can do the front and the back of these. The back is mostly just converting from one to the other. So the top section of the back, you just need to rewrite. But the bottom section, you do need to simplify. Just like here, the top sections, you're just rewriting. The bottom section, you're also going to simplify. And it says that in the directions. All right, guys, email me with any questions. Thanks.